Dear friends, my name is Hemanta. Again, welcome to this YouTube platform, that is your e-learning hub YouTube channel. In our earlier classes, we have talked about the different types of function and what are the other or special type of functions that are very much essential while dealing with the economic operation or in your mathematical operation in economics. Okay, so from the students class, we shall be learning about your limits and continuity. What is the meaning of limits and what is the meaning of continuity, and how the limits can be derived, whether the limit exists or not, that we are going to see. Clear? So let's talk about what do you mean by limit, or what we can call whether there is a exist the limit exists or not for a particular function. Clear? So can you tell me what do you mean by limit? So here we can say that the limit in the present context means a constant value to which the function of a variable, say fx, approaches as the value x approaches a given value, say x. It means when there is a term that is given or a function of x notation that is given. Clear? Okay? Where the x value that approaches towards a constant value. Okay? Then we can have a limit of that particular function. Clear? If that x value approaches to that particular constant value, okay, then we are going to define, or we can have a particular or constant value of the what, the functional value. Okay, or the value of the function, we can say. Clear? So in that case, we can say there the limit exists. Clear? Thus a limit of a function, say L, we can say it is L. Clear? Is the value to which fx approaches as the variable x approaches a given value a. It means, what does it mean? The limit of a function L, what does it represent? Suppose let it equal to function of x. Okay, and when we approaches the value towards your a, okay, from, we can say from the upper side and from the lower side, or from the left hand and from the right hand, we can see. Clear? So then we can able to get a particular value of this fx, or the limit value. Clear? So that is called your what, limit of the function. Clear? The function fx approaches the fixed constant. It means when we are approaching towards that particular constant value a. Clear? Then the function fx that also approaches toward a particular constant value. Okay, or sorry, that not actually a, that fx that approaches toward a particular constant value, let's suppose it is b, then this b is called your what, limit of the function. Clear? So it simply says that when the variable or the x that approaches towards a particular constant value, okay, then what will be the value of the function, or what will be the value of the function, and that must approaches towards a constant value, and that constant value called is what, limit of the function. Clear? I think understood what is the meaning of your limit. But in some cases we actually exactly cannot derive the that particular constant. So what will happen, we approaches towards that particular constant value of the function. Clear? So so whatever the difference that will be in between your limit value and the what, your functional value of that, for example fx, and the limit value. Okay, it means I want to simply say that when we are approaching towards the value a, okay, when the x value approaches toward the a, then what will happen, your functional value fx that also approaches towards the limit value. Okay, but in some cases we exactly may not also derive the limit value. Clear? Then what will happen, we try to get a such type of what value which is very much near to that limit value. Okay, it means we can say the difference between the functional value fx and the limit value, that should be minimum, or that should be smaller. Clear? Clear? When x approaches towards the a, or the toward that constant value, okay, towards that constant, what will happen, your fx, or the functional value that also approaches towards the add value. Okay, But in some cases, what will happen? We are not going to exactly derive the particular limit value. Then in that case, what will happen? We'll take the smaller and smaller value, or the difference between the value of the function and the limit. And we are taking that smaller difference between the value of the function and the limit value. Clear?
Yes.
So in this case, we can derive the limit of the function. So here it is clearly stated that the limit in such a manner that the difference between the function and the constant, your function of x, and the limit value can be made smaller and smaller than any smallest possible positive number. Okay, we can have the any smaller positive number. Clear? So in this case, we can say that is denoted as a what? Epsilon. That is denoted as epsilon, or read as epsilon. Okay,
Okay.
as we may choose, and this difference continues to remain less than the chosen positive number. It means the epsilon value that must be smaller and smaller. Clear? So long as the value, so long as the variable x continues to appear nearer to x, that I have already clearly explained. Okay,
Okay.
it means when x tends to a, or that x approaches towards the a, so we are getting the epsilon value, or the epsilon value means what? The difference between your functional value fx minus the limit. Okay, so
Okay.
that value is called your what? Epsilon, and that epsilon must be smaller and smaller, and that must be positive quantity. Clear? Okay,
Yes.
then the particular value chosen for it. So this means that as the variable x approaches closer and closer to a, the function fx approaches closer and closer to the limit value. Okay, so what does it simply say? As I have already told you that if the x approaches towards the particular value, okay, or that constant value, then function of the value that approaches towards the limit value. Clear?
Yes.
Okay, understood?
Okay.
This means that the variable x approaches closer and closer to a, the function fx approaches closer and closer to limit value. Clear?
Yes.
Okay. So here we are taking the difference. We are taking the difference of your what? Fx at that actual value of the function. Okay, and the limit value, that is your what? Del we can take. Okay.
Yes.
So and whatever that positive value we have taken, or the positive constant, that is called your what? Epsilon. Clear? Then always you must remember that the difference between the functional value and the limit, that must be, or that the your what? Del must be less than the epsilon. Clear?
Yes.
And epsilon means what? That positive value that we have taken. Clear? Okay. So let's, so what here is taken that if x approaches the, if value of the, if x approaches the a, then what will happen? The functional value fx, okay, that
Yes.
approaches toward the limit value, and the difference between these two, that is your what? The difference between these two is denoted as your what? Del. Then del must be smaller and smaller. Okay, but remember that del must be less than the positive epsilon value. Okay, that we
Yes.
have taken. Clear?
Yes.
So that is the thing. So we'll take an example and we'll see how that limit can be derived. Clear? So here we have taken an example. Let fx equal to, let your, let we can take fx equal to what? Fx equal to 2x plus 5. Clear? 2x plus 5 we can take. Clear? Okay, and suppose x tends to 2, we are taking their positive value, or the epsilon h, x tends to 2. Clear? Okay, then the how we can derive the limit of the function? We can say the limit value of this function is equal to limit x tends to 2. It means when x approaches toward the 2, or it will become the value of 2, then what will happen? Your, the limit will
Function
2x plus
approaches
5,
toward.
2x plus 5. Okay, then
Yes.
in this case what will happen? In place of x we can write down it is 2, then plus 5. Okay,
Yes.
then what will happen? Then what will happen? 2 into 2 4 plus 5, this is equal to 9, and that 9 is the limit value, and that 9 is the limit value.
Limit
Okay,
value.
L is the what? 9 in this case,
L.
because when x becomes your what? 2, or when x equal to 2, then we are getting a limit value 9. Clear?
Okay.
So in this case we can say if x equal to 2, then our limit exists, and that is your what? 9. Clear?
9. Yes.
Okay,
Yes.
so this is given in this example. But we can say that, so this limit can be, or function, the limit value of the function can be represented in a two way. Okay, or that can be proved in a what? From the lower and the upper side. Okay,
Okay.
it means whenever we are taking the value of a x, we are taking the value of x equal to a, sorry, x equal to 2 here. Okay, so that 2 we are approaching towards the particular value 2. Okay,
Okay.
so we are having the two approaches, that is from lower side, and from the lower side what will happen? We are taking the nearer value of the two. Okay, so we'll start from the what? For example, 1.9. Okay, then
Yeah.
1.99, then 1.999, then 1.9999, and so on. Clear? So it means that 1.9 and 1.99, if it is increasing, then what will happen? That particular value, okay, the value, the x that approaches toward the 2, okay, that we have taken the positive value. Clear? Then what will happen? In this case our functional value also get changed. Clear?
Yes. Yes.
Our functional value also get changed. So you derive the what will be the functional value. Suppose we are taking the x equal to, suppose we are taking the x equal to 1.9. Okay, so let's take the what will be the value? Fx plus 5. Okay, we have taken the functional form fx plus 5. Clear? So here 2 into 1.9 will take. Okay, plus 5 will take. Understood or not?
Yes.
Then what will be this value? What will be this value?
8. Okay.
So here what will happen? We are multiplying the value. Okay, so let's get the value 2 into 1.9. Okay, plus 5. What then? What we are getting? We are getting 3.8. Okay,
Plus 5.
plus 5. Then this is equal to what? Your 8.8. Clear? In this way, by putting the value of the x as 1.99, 1.999, we can have these values. We can have these values. It means that particular value also approaches towards the 9. Clear? The limit value 9. So it simply says that when we approaching towards the x equal to 2 from the lower side, okay, our
Yeah.
the limit value of the function that approaches toward the 9. Okay, and 9 means that your limit value. Clear?
Okay.
So this is the thing. Okay, and what should be your difference between, or what is your what? Your uh, the difference between the functional value and your limit value, that should be here, that the limit value is 9. Okay, and if we are getting the actual value of the function by taking the 1.9 as x, then what will happen? We are getting 8.8. Okay,
Okay.
so the 8.8, 8.8, clear, minus 9, this is equal to how much? This is equal to minus 0.2. Okay,
Yes.
so that is the actually your difference between your functional value and the limit value, and that should be minimum. Actually that should be minimum, or that should be reduced while we are calculating the limit. Okay,
Okay.
so if you take that 1.99 as your what? X value, then what will happen? The function will become, the functional value will become 8.98. Clear?
Yes.
And if you take the difference between this 8.98 and 9, 8.98 and 9, we are going to get a value that is minus 0.02.
Yes.
Clear? In this way you will take, unless and until the minimum value is achieved. Clear?
Yes.
So if we increasing the value of the x, then what will happen? The functional value fx, that approaches toward that limit value. Okay, it simply says that the difference between these two declines are smaller and smaller. Clear? So
Okay.
then we can able to get the limit value. Clear? It must be seen
Yes.
that the difference between the fx and the limit is less than a positive number. It is less than a positive number. Clear?
Yes.
Okay, so you have to notice that it is must be less than a positive number. So what about the difference that is arises in between your what fx and your limit value, or the functional value and the limit value, that must be less than your what positive number. What about the positive number? That must be less than that positive number. Clear? Understood or not?
Yes.
Then come to the what your from the upper side. From the upper side, how we are going to calculate the limit? Okay, and from the upper side, we'll take the value of x.
Yes.
We'll take the value of x is equal to 2.1. Okay, and that putting the value of 2.1 in the function, then what we are going to get? What we are going to get? 2x plus
Two.
5. Let's put 2 into 2 into 1 point, sorry, 2 into 2 into 2.1 plus 5. Okay,
Yes.
then what will happen? What will happen? This
It will be 4.2 plus 5.
4.2 plus 5. Okay,
Yes.
then this will become 9.2. It means your functional value will become 9.2. Okay, and what is
Okay.
your actual limit value? The limit value is 9. Okay,
Yes.
then
Yes.
difference between these two is, the difference between
Zero.
these two is 9.2 minus
Minus 9.
minus 9. This is equal to 0.2. It means it is also less than that particular value, positive value. Okay,
Yes. Yes.
clear?
Yes.
So in this way, if you increase,
Decrease the value.
yes, sorry, in this way, if you increase the value of the, if you decrease the value of the what, your x
2.1 towards 2.
towards your 2. Okay, it
Yes.
means whenever we are taking the x is equal to 2.1, from the 2.1 we are going to declining the value. Okay,
Yes.
it means
Yes.
we will take the x is equal to
2.01.
2.01. Okay,
2.001.
2.00001. In this way, then what will happen? Your the functional value that will approaches toward the 9. Okay, from
Yes.
9.02 to 9.002, and in this way, it means this also, the difference between these also, that will decline. Clear? And
Okay.
it will approaches toward the particular value, that your limit value 9. Clear?
Clear.
So it must be seen that as moves at x moves closer and closer to the 2, then what will happen? Your functional value fx moves closer and closer to the limit value n, or your 9. Clear?
Yes.
So from the upper side and from the lower side also we understood what is the, how can you get the limit value. Clear? So here we have to, another thing you have to notice is that in the above case, the smallest possible positive number, that is your epsilon, okay, to be taken must be more than the value of the standard deviation. So, or sigma we can say here, in case of your what upper limit we are talking about. Clear? Understood or not? Hello?
Yes.
So that epsilon, that must be greater than your what? Your greater than your what? Sigma. Okay?
Sigma. Yes.
Okay, sorry, greater than your delta, we can say.
Delta n.
Okay, that epsilon value that must be greater than your delta. Clear?
Okay.
But whenever we are talking about the lower value or the lower limit, then what will happen? Your epsilon value
Lo- less than
less than the
delta.
delta. Clear? So
Okay.
the point number 3 that you have to notice is that the limit of the function x approaches a is not the value of the function when x equal to a. Clear? The limit of the function x approaches a, when the limit of the value, or that x approaches the a, then what will happen? It is not the value of the function when x equal to a. It means when x equal to a, that is not the limit of the function. We are taking from the both sides. Clear? Then if the will derive how the limit of the value is function, if the LHS, okay, and RHS both get equal and your limit value will equal, then only we can have the limit will exist. Clear?
Clear.
We'll see that. Okay.
Okay.
It means simply if x approaches a is not the value of the function when x equal to a. It is not exactly same. So it says that it is not exactly same. Okay. In the above example, the limit of the function 9, whereas the value of the function is indeterminate or indefinite. So in this case, we can say the value of the function is indeterminate or indefinite. Okay. So let's see what is the definition of limit. Okay.
Okay.
The limit is said to be the, or L is said to be the limit of the function, clear, fx as x approaches a, as x approaches a, if the difference between the limit and the functional value can be made as small as we can by taking the x sufficiently nearer to a, and is denoted symbolically limit. It is denoted symbolically limit x tends to a function of x, this is equal to L. Clear? It simply says that when we are approaching towards the a or a constant value of the what x, then what will happen? Your functional value fx that approaches toward the limit value. Clear? And the difference between these two, functional value fx and the limit value, that should be minimum and minimum, or that should be smaller and smaller. Clear? And we can denote this in terms of your what? Limit x tends to a, or that constant value, or that particular constant or positive constant, where fx this is equal to L we can take, or the limit value we can take. Clear? It means this is if x tends to the particular positive number and the functional value fx that approaches toward your limit value, or that equal to the limit value. Clear? So let's say what are the characteristics of your what? Limit. Okay, there are some essential characteristics of your what? Limit of the function. Clear? So let's see what are the essential characteristics. The variable x may assume any value sufficiently nearer to x. It means the x, the value whatever you are taking, the x, the value of the x that sufficiently nearer to that particular constant value from the both upper side and the lower side, but never equal to a. But you have to remember that that will approaches toward a, but it will never equal to a. Clear? Understood or not?
Yes.
So whenever we are taking the lower side and the upper side, that approaches towards your particular constant value a, but it will never equal to x equal to a, we can say. So that is the first property. Clear? Next come to the what? The second property is the quantity limit x tends to a function depends only on the values of fx. Clear? For x nearer to a, but not for x equal to a. So it means that limit x tends to a, this is the functional value. Clear? For the different values of the x and the different values that approaches toward the constant, there is a. Clear? Then that is not actually equal to, that is not equal to what? That is not equal to what? X equal to a. Whenever you are taking the x equal to a, then functional value will become the limit value. Clear? Whether it will become the limit value or not. Understood or not what I am saying?
Yes.
So here let's come to the what? Third characteristics, and that is that as the x gets closer and closer to a, the value of the fx might not approach any fixed number, and in such a case we must say that the limit does not exist. Clear? So when x approaches the a, towards the a, we may not have a fixed number of the limit value x tends to a and functional value of this. Clear? It means when x approaches a, we may not have a functional value that is in fixed number, and in that case what will happen, we call limit does not exist. Limit of the function does not exist. Clear? If that particular functional value does not approaches towards a fixed number. Clear? Understood or not?
Yes.
So in that case we can say the limit of the function does not exist. Okay. Next, come to the what your fourth number characteristics. The difference between the fx or the functional value and the limit always remains less and smaller as possible. Positive number as may be chosen. It means you will take the smallest value of the difference between the functional value fx and your what limit value. Clear? That I have already told you. Okay. So these are some meaning and definitions of your characteristics and how we are going to derive the characteristics or your what limit value. Clear? So I think you are actually clear about all these things. How what is the meaning of limit and how we are going to derive the limit and what is the your upper and the what lower side of the limit how we are going to derive. Clear? So this much for today. Thank you.